Now, the next interesting operation is pooling. And again, there are like several different reasons why pooling is useful in your CNNs. I will again give you a couple of those. The first interesting aspect is it helps you in reducing the memory consumption. And if you think that somewhere in the network, it's actually taking a lot of memory, or you can say like a lot of parameters, you can just apply pooling and reduce the size or the shape of your activation map. And pooling it's also called subsampling, which when we're discussing like CNNs at the beginning, we saw those subsampling layers in the CNN architecture, right? So pooling is exactly that operation. So that's one motivation. The other motivation is it helps you in bringing like some kind of invariance in your network with respect to translations. And this is very interesting because what will happen is, if let's say you have your image and there is some object in the image. So if there is some translation, like the position where the object lies in that input image, if that changes, so that will change like the activation values as well, right? Because the position has changed. But if you're using pooling, so pooling is basically looking at like a small neighborhood and then just aggregating the values. So if you use pooling, then even if you have like slight variation in the translation, the pooling operation will make sure that that operation or that translation doesn't affect the features which you are extracting. Okay, I will go over that in more detail. Let me first explain like how pooling works. So let's say you have this kind of activation map. This could be your image as well, or some kind of feature map, intermediate feature map in your network. And of course, I'm showing just like two-dimensional here. You will have like depth as well. So pooling means you consider like a very small neighborhood. In this case, the neighborhood is 2 cross 2. Okay, so what you do is you, based on all these values, you just extract like one value. Okay, and there are various different versions of pooling. For example, like in this case, I'm showing you max pooling and this is average pooling. Max pooling is you just pick the maximum value in this neighborhood. Okay, so in this case, it's 20. You can just pick that. And in this case, it's 30. You will just pick that. Okay, same for these two. In this case, 112, in this case, 37. Okay, so if you have such an activation map and if you perform max pooling operation on this, your output is going to be this. And similarly, average pooling is almost similar, but instead of like taking the maximum, it's kind of taking the average. So if you think about this, average pooling is in a way like using the box filter, right? A normalized box filter. But in this case, I mean, and of course, like implementation wise, it might be using box filter, but we don't care about that. Conceptually, it's different, right? We are just taking average of these values. So we don't need any kernel for that. It's a different story, like how it's implemented mathematically. But conceptually, we don't need any kernel. We don't need any kernel for max pooling. We don't need any kernel for average pooling. So this operation can be performed by just looking at these values. Okay, we don't need anything else. Now, again, there are some hyperparameters here. The first hyperparameter is what is the shape of like this neighborhood, and that you can say like is the way you're using, let's say, the shape of the kernel. You do have like a hypothetical kernel without any parameters. So in this case, it's 2 cross 2. So the pooling operation is 2 cross 2. And again, you have like some kind of stride because you're not placing at all the locations. In this case, the stride is 2. Okay, because this is the first location you put, then you skip this one and then go to this one. Okay, so those are the hyperparameters which you require for pooling operation. So as I said, like it makes your representation smaller. And ideally, I mean, you have depth in your activation map, but max pooling is performed independently for each activation map. You don't need like to understand the relation between those activation maps, and which is different from your convolution operation, because whatever kernel you have for your convolution, it actually spans across the depth of the activation map, right? It considers all the values. But pooling is looking at each activation map independently, which means that whatever depth you have in your activation map, that is going to be preserved. So if you look at this, if your feature map is 224, 224, and 64, okay, so 224, 224 is height and width, 64 is the depth. Then what you will do is you will take a slice of 224, 224 from this feature map, and you will perform the downsampling or the pooling operation. Let's say in this case, I think if you try to reduce it by half, it's going to be 112, 112. I think for this, you can use maybe a 2x2 kernel with a stride of 2. That's going to give you 112, 112. And you perform this downsampling independently on all the possible slices of this activation map. And that will be your pooling operation. Okay, so then you can see that the output, the depth is not changing. It's still 64. But the resolution or the X and Y axis, it reduced to 112, 112. So two hyperparameters, kernel size and stride. Of course, like it's hypothetical because we don't have any kernel here. We don't need any kernel. So this is like, again, a simple example, 2x2 filter and a stride of 2. And if this is max pooling, you will just pick these maximum values, 6 in this case, 8 in this case, 3 in this case, and 4 in this case. So let's try to understand like why it was translation invariant. For example, at this location, this pixel is actually highly active, which means that whatever pattern you are trying to look in your input data, it was present at this location. Okay, that's why you got 6. It was not present at this location. It's close to 0, right? Very small than 6. Now, let's say if you move that pattern or that object in your input image in this direction, or let's say towards top, so that it moved to this location. So then what will happen is in your activation map, you will get a 6 over here, right? Because it will be present at this location. But now if you look at the result of such a translation operation, this location is still going to give you a 6 because instead of at this location, you will have 6 at this location. So the final output is not going to change. So that's why this max pooling operation actually makes your network translation invariant.